Welcome to another video of Math with Jonas, where I try and take the complicated and make it real simple for you. Today we got our first viewer requested video. So we're going to be looking at the topic of proving triangles congruent. And we're going to look at it by doing some proofs. So just 3 examples today. But we're going to work on all the different, well, not all of them, but most of the different theorems, something like side, 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 or side, angle, side, to see if we can prove some triangles being congruent today. I'll talk a little bit about, how a proof works as well, but let's just jump straight in here to our first example. So we see a picture, it almost looks like an hourglass. It's a couple of triangles on there. And we're given some information, and then we have something we want to prove. So basically with any proof, what you're doing is typically you're given some information, but you're taking the information you are given and you're trying to figure out some kind of line of reasoning about, in the case of proving triangles congruent, how do I take this information I've been given so that I can say, well, those 2 sides are the same, or those 2 angles are the same, something like that. You can pretty much only work with the information you're given, and of course there's going to be some other things you're expected to know, and we'll see some of that in today's video. You're going to have to also, you're going to be expected to know some things, and you're going to have to apply those reasonings in your proof. As a basic tip, it can always change, there's always exceptions, but as a basic tip, you start your proof with your given stuff, and then there's all your reasoning, and then at the bottom is like a conclusion. All right, I've proved this thing, and this is the theorem Y. After all this reasoning, I can say this. All right, so in this one here, we've got 2 triangles. We're trying to prove that triangle ABE. So you're just following the corners of the triangle ABE. So this triangle up here is congruent or equal to triangle DCE. So just follow the letters. Okay. So we're talking about the 2 triangles we can clearly see. We're given some information. And when you're given information and it's not labeled on your picture, number 1 pro tip for proofs with triangles: label the information on your picture. So the first thing we're given is that segment AB is congruent or equal to segment CD. And just so you know, you might see the segment symbol above these. Probably should have had those there, but you're not going to see them throughout. I might just write them in. Also, you might see the congruent symbol. It looks like an equal sign. It's got the little squiggly bit above it. In essence, it means they're the same thing. You can think of it like equals if it's a bit confusing for you. So when we mark this, so segment AB is the same length as segment CD. We just use a little mark on each one. So I'll put 1 mark here, and then let's find segment CD. Just connect the letters, and we'll put a mark there. So now we've got a pair of sides that are congruent in our triangles. And if you know your acronyms, I got a bunch of A's and S's. This is an S. We've said this top side AB is the same as this side down here, CD. So that's one of the S's in our triangle proofs, but more on that in a second. Now we have a second given piece of information. Actually, before we jump into that, let's start writing this down. So the first thing we've done so far is we said AB is equal to CD. Those are segments. And the reason we said that was because that was given to us. So we just have to write given. Really, the big thing there was labeling it on our diagram. That was the big thing. Now, we have a second thing here that's given to us, so we can just write it down. So segment AB. And if you're not sure what these 2 lines mean as a symbol, it means parallel. So segment AB is parallel to segment CD. And again, it's important to label these on your picture. Typically what you see is instead of that mark that goes up and down, you see a little arrow. So I'll put one on the top one on the bottom one. And since both those segments have an arrow, that means they are parallel. That's the symbol we typically use for that. This was also given, so we can just write that in. And now what we have to do is take this clue that our two segments are parallel and do something with it. We have to infer something or know something and connect it to something else. So typically when you're given a clue that two lines are parallel and you're working with proofs of saying triangles are congruent, they're talking about alternate interior angles. And just a quick refresher for if you need it. You've seen the picture, you've got two lines that are parallel, and then there's some other line that cuts through them. Let's extend that one a little bit. And it creates all these angle relationships, and maybe you've heard of alternate interior angles. Something like that angle and that angle. So these two angles are the same. Since these lines are parallel, that's one of those properties. So that's what we're referencing here. So if we look at our two parallel lines, A, B, and C, D, we have an angle A up here in the corner. And because we know the lines are parallel, we're trying to figure out what is its alternate interior angle. So basically it's the alternate angle on the other side of this line AD for our other triangles. So that would be down here. So we know that angle A is the same thing as angle D. And I'll abbreviate. I'll say it slow, but I'll abbreviate in writing. Alternate interior angles. So we know A and D, angle A and angle D in our picture are the same from that given clue. And we also actually know, let's see if we can just change the color here for a second. There's another set of alternate interior angles. So this is all just from this second clue here. All from that second clue. And so we have angle B. And what's the one on the other side of this? This is called the transversal, by the way, but the line that cuts through our parallel lines, that's this here. And that's this angle C. So we also know angle B is the same thing as angle C here. And it's the exact same reason, alternate interior angles. So same thing. Okay, so now at this point, let's see if we have enough information and that we can say that, remember what we're trying to prove. Triangle ABE is congruent to triangle DCE. So let's see if we have enough information. So I'm just going to pick one of my triangles. I'll pick the one up top. And let's look at the information that we have on our picture. So the relationship between the two triangles. So here we have, there is an angle. We have this angle is congruent to the one down here. So we have an angle A. Meaning A for angle. Not, I know this is coincidentally angle A. It'll make more sense in a second. Now I'm just going to move across to my next marking here. And just this one here. We don't need the parallel one for this. That was a clue. That gave us more information. But here we're looking for congruent sides and angles. So here we have a side, right? We said side AB is the same as side CD. So now we have a side here. And then lastly, we have this one over here. And again, what did we say here? Well, we said angle B is the same as angle C. They were alternate interior angles. So again, that's another angle. So we put an A. And you've basically just written out your theorem. This is going to be angle side angle, ASA. Back to the last part. We got to prove, or we can write what we're proving as our last statement here. So triangle ABE is congruent to, and you can include a little congruent squiggly, triangle DCE. And we're using our triangle theorems now to complete this, like for our reasoning. So again, we had angle, and then there was a side, and there was an angle. So we have, in this order, angle, side, angle. If you're one step ahead, yes, you could have used the vertical angles in this. So you could have only used one of the alternate interior angles. You could have said angle AEB is congruent to angle DEC because they are vertical angles. And if that's the way you went, then you would be using angle, angle, side. So if you're thinking about that, that's a possibility here. But I'm going to leave this proof as is. All right, let's check out what we have on the next example. So we have a four-sided shape, ABDC, or ACDB, and we're given a piece of information. E is the midpoint of segment BC and segment AD. And then we have to prove, so good habit, look at what you're given, look at what you have to prove, get that all in your head, and then start thinking about it. So we have to prove triangle AEC. Let's do a quick little highlight. Triangle AEC, so that's this triangle around here, is congruent to triangle DEB. Okay, so that's this one over here. So we're trying to prove that those two triangles are congruent. So let's start our actual proof here, and we'll just start with what's given. E is midpoint of BC, segment BC, and segment AD. And just for a reason, that's given, so we'll just write given. I don't think this proof would be doable. Maybe it is, but I don't think it's doable unless you're given that piece of information. Now, like I said in the last example, you want to mark this on your diagram. So let me switch colors here. And let's start. So E is the midpoint of segment BC. So here's segment BC. If E is the midpoint, so technically speaking, if it's the midpoint, it is right in the exact middle of that segment. It is the exact halfway point, meaning here's the midpoint. Everything to the left is equal to everything to the right of it. Okay, that's what it means. And so we can put our markings down. So E is the midpoint of BC. We know this. Segment CE is congruent to segment EB. So from that clue, we can write that in now. So segment EC is congruent to segment BE. In that, you can either write definition of a midpoint. You can probably write midpoint theorem. I'll go ahead and write definition, abbreviated, definition of midpoint. All right, and then we have a similar thing because E is the midpoint of segment BC, but also segment AD. So we're going to put the marks on there. So that means this half equals this half, so we'll just mark it on here. 1, 2, 1, 2. And if you're like, why is he using 2 marks instead of 1? Well, if I used 1 mark on both of these that I just put 2 on, that's saying all 4 of those segments are the exact same because they all have 1 mark. I don't actually know that though. All I know is that AE is the same as ED because that segment got split in half by E. And I know CE is the same as BE because that segment got split by E. I don't know that AD and BC are the same length. So we got to use different marks. That's all we know. Okay, so we have exhausted, well, we should write that down, but other than that, we have exhausted that first given clue. So let's just write it down real quick. Segment AE is congruent to segment DE. And that's the exact same reason, definition of midpoint. Okay, so now for like, okay, can we prove the triangles are congruent? Right now we have a side and a side. So just looking at this yellow triangle on the left, we have a side and a side. That's not enough to prove the triangles are congruent. So you can examine, you know, is there something I can do with AAC and BD over here? Because if we get a third side, we can use side, side, side. However, I'm not seeing that in this problem. So let's start thinking about angles. And what you have here in the middle. So with this angle here, AEC or CEA, and this angle here, BED like bed, or DEB, however you want to call it, those angles are called vertical angles. So, and that's a symbol for angle. So vertical angles. So basically, if you have two lines cross each other, it forms two pairs of opposite angles. So like one's up here, one's down here, and then you have the left and right pair. Those are going to be equal. So the left and the right are equal. The top and the bottom angles are also equal. Anytime you have two lines that cross each other like that, you create those equal angles. The name for them is vertical angles. So in our reasoning here, we want to say that we just marked it on the diagram, but now we have to write it out. And I don't want to avoid the pitfall of saying angle E. Angle E is too unspecific in this example. I don't know what you're talking about if you say angle E. So this is one of those situations you want to use three letters for your angle. So we'll say here, okay, E is our vertex, so let's go AEC. So angle AEC is congruent to, and then let's look at the other triangle here. So again, similar thing, let's keep our vertex in the middle, and BED. And we'll call it, and again, you can say DEB. You can flip the last, or the first and the last letter. I just kind of wanted to spell bed. That's why I'm writing it like that. I really just wanted to spell bed. I find it fun to make little words when they present themselves in math problems. And again, for our reasoning, how did we know those two angles were equal? Well, they're vertical angles. So we'll write vertical. I usually just use the symbol angles. You can write out the word angles. And if you want, you can say theorem. Not the utmost importance, but okay, let's be official here. And okay, so now we have, remember we had the two sides from earlier, but now we have this angle here. So let's tally these up. So let's just go in order. I'll start with this one. That's a side. Here's an angle, and here's a side. So we meet one of our triangle congruence theorems. That's SAS. Side, angle, side, side, angle, side, and that angle is nestled right in between the two sides. So we can now write our final proof here, or the final step of our proof. We've got all the information we need, so we can wrap this up. And we're just going to copy down what we have to prove. Triangle AEC is congruent to triangle DEB. And our reasoning for that is, again, is this theorem over here. We tallied up a side, angle, side. That's our theorem that proves the triangles are congruent. We don't need to know everything about each triangle. We just need to know enough. And in this case, SAS, side, angle, side, was enough. Okay, let's go ahead and take a look at our last proof here. This one's one of the lesser known theorems. It's pretty popular, but it's no side, 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 angle, angle, side, angle, 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 side. It's the other one. It's like the black sheep of all the triangle proofs. And you'll get a refresher if you have forgotten what theorem I'm talking about, or maybe you don't know. Maybe it's been hidden from you. Here we go. So we're given AD equals BC. First thing you want to do is mark your diagram. So segment AD is congruent to segment BC. Okay, so we put one mark next to each one. That means those two lines are the same length. And we can write that out. AD is congruent to segment BC. And our reason for that is, well, how did we know? It was given to us. So we just write given. All right. And for our next step, we have another piece of given information. And you can kind of, since they're the same thing, you can kind of smush them together. So we have segment AB is, and if you don't know what this symbol is, it means perpendicular. Two lines are perpendicular if they intersect at a 90-degree angle or a right angle. So we have segment AB is perpendicular to segment BD, comma, because we have a very similar thing, segment DB is perpendicular to segment CD. And again, that was all given, so we can just write that down. But okay, now what we got to focus on is, you know, the first given clue, well, it gives us a side, right? It gives us one of those S's. It gives us a side here. But what the heck does this clue do? Because right now we just know two lines are perpendicular, but that doesn't tell us if a side or the angle is the same. So let's go back to marking our diagram. So segment AB, this one here, is perpendicular to segment BD. So that means they intersect at a right angle. So we're going to put this little symbol here for that. And then we have a similar thing going on with our other given. Segment DB is perpendicular to segment CD. So again, this intersection here forms that right angle. And again, we'll kind of smush those two pieces of information together. So angle, and I think no, let's be specific. Let's use three letters. So angle ABD, and what was our other right angle? CDB. So we go from C to D to B. It's like tracing the angle. They are 90 degrees. And if you're like, why? You might, even if you knew about perpendicular lines, you might go, why? Well, it's exactly that. It's just a definition of perpendicular lines. So definition of perpendicular lines. So as soon as you start, when you're working with triangle proofs, and as soon as you get into right triangles, there's a new theorem that opens up. And it's HL. H stands for hypotenuse. I'll abbreviate it as hypot. And L stands for leg. So in any right triangle, it has two legs, and they form that right angle in the triangle. And then it has a hypotenuse, and that's that other side. Okay. And in our theorem here, in the hypotenuse leg theorem, it's a little bit shorter for right triangles, but basically this. If you have that right triangle, or two of them, and you can say that, okay, the hypotenuses are the same length, and one of those legs are the same length, that is all you need. All you need to say the two triangles are congruent when you have right triangles. And right now we know we have right triangles. We can see that the hypotenuses, so in the bottom triangle, that's segment BC. On the top triangle, that's segment AD. We have congruent hypotenuses. So can we say, is there a way we can get the legs to be the same? So this next step is what I like to call, it's not actually called this. You can't actually write this down in your proofs. Well, you could, but you might lose some points. But basically, the way I see it is like, picture two bedrooms, but they share the same wall, right? Well, the wall's going to be the same length. Doesn't matter if you're in the bedroom on the right or the bedroom on the left. If they share a wall, it's going to be the exact same length because they're sharing the wall. That reminds me of the good old days before you know, cell phones, and you were a kid, you were bored. And I remember my brother and I, we would just like knock on the wall. We shared a wall, and we would just kind of knock back and forth. And sometimes it was fun. Sometimes it was extremely obnoxious. Anyways, so you can see here in our triangle, you can see that this segment BD here, so anyway, just go over the yellow highlight there. You can see that segment is like the shared wall of our triangles. It repeats. It happens in both triangles have that side. So we just want to say that segment BD is congruent to, and usually I just like to flip the letters around. You don't have to. DB. And the reason for that is the reflexive property. And I think you can call it reflexive. I think you can call it reflective. I don't know if there's a proper term or if they're both interchangeable, but I like saying reflexive property. So that's the official wording for when two triangles share a wall. And if we want to mark that on our diagram, so using 2 marks, because it's not the same length as the hypotenuse, so I got to use 2 marks. And since it's the same line, I only have to put it there once, just to show the reader, hey, I recognize that this is the same in both the top and the bottom triangle. And we circle up, what do we have given here? Well, because we have right triangles, we want to focus on, can we use HL? Well, this is a hypotenuse. And segment BD or DB is a leg. So we do meet that condition. So in our final step of our proof, we're going to copy down what we see. Triangle ABD is congruent to triangle CDB. And what theorem did we use? Well, the hypotenuse leg theorem, or commonly abbreviated HL theorem. Okay, and that about wraps it up for our congruent triangle proofs today. There's a whole lot more stuff you can do with these, but this is meant as a way to get started. If I'm only looking at 2 triangles, how do I know they're the same? The reflexive property comes up a lot. Vertical angles comes up a lot. You gotta be on the lookout for those. Those aren't always given to you. You have to be able to spot them. Oh, that's the same side in both. Oh, those are vertical angles. So you have to be able to spot those and recognize them in order to complete your proofs. But yes, I'll wrap it up there. If you like the video, go ahead and give it a thumbs up. Comments always appreciated. Also, if you want to see more of my content, ring the bell. I've got an exciting new idea for a little series I'm going to do. I won't spill beans quite yet, but it will be releasing soon. And I'll see you on the next one.